pinpoint of darkness hovers above a city skyline. No sound, no light, no warning, only the slow pull of gravity. In seconds, the laws of physics begin to fail. Streetlights bend, buildings groan. The air itself starts to move, drawn upward toward an invisible hunger. This is not a bomb, not an asteroid. It's a black hole, and it has just appeared on Earth. Let's imagine the impossible. Somehow, through an accident, an experiment, or a tear in space-time, a small black hole forms on our planet. Not the kind born from collapsing stars, not something thousands of kilometers across. No, something smaller. Perhaps a micro black hole, no larger than an atom, yet heavier than a mountain. A gravitational singularity, pure, collapsed space where the laws of physics surrender. Its gravity is infinite at the center, but its reach depends on size. The smaller the black hole, the more violently it pulls, and once it appears, it cannot be stopped. It can only consume. To understand what happens next, we must understand what a black hole is. Every black hole hides an invisible boundary, the event horizon. It's the line between existence and oblivion. Cross it, and you can never return. Not light, not matter, not even information itself. Inside, gravity crushes everything into a single point, a singularity, a region where density becomes infinite and the known universe loses meaning. Around that point, space and time distort violently. Seconds stretch into eternities. Light bends in circles, unable to escape the trap it helped create. This is the most powerful phenomenon in nature, a place where time slows, matter dies, and reality folds in on itself. Now imagine this not in a distant galaxy, but hanging silently above your city. Real black holes are born in death, the death of stars. When a star many times the mass of our sun collapses under its own gravity, it compresses beyond recognition, and a black hole is born. These stellar black holes are massive, sometimes tens of kilometers across, yet containing the mass of entire suns. And yet, some scientists once wondered, could the Large Hadron Collider, the world's most powerful particle accelerator, accidentally create microscopic black holes? The answer, thankfully, was no. The energy required to make one that could survive longer than a fraction of a second far exceeds anything humanity can produce. But let's suspend disbelief. Let's say it did happen. And this time, the black hole doesn't evaporate. It grows. It starts small. At first, no one notices. The black hole hangs silently, invisible except for how it bends the light behind it. A faint shimmer, like heat above asphalt. Then, things start to move. Loose papers drift upward. Street signs tilt. Metal creaks as gravity begins to warp. In a radius of a few meters, the pull is already stronger than anything on Earth. Objects rise and vanish, drawn toward the void. Cars twist like toys. Buildings stretch. Foundations groaning. And then they break. The black hole feeds. Every atom it consumes adds to its mass, and with every gram, its hunger grows. Within minutes, the surrounding atmosphere begins to spiral inward. A roaring storm of air, dust, and debris forms a deadly accretion disk, superheated plasma circling the hole at nearly the speed of light. The temperature surges, metal melts, concrete vaporizes. The black hole swells, from the size of a pinhead to a marble, then to a stone, then to a meteorite. Every increase multiplies its reach. Gravity ripples outward, stronger, faster, unstoppable. Within an hour, the city collapses into a singular point, its entire mass crushed into an invisible speck smaller than an atom. The ground shakes, Shockwaves ripple through the mantle. Tectonic plates twist and snap like paper. If it started above ground, it would soon sink, drawn toward the planet's center, pulled by its own growing gravity. And there, at the core of the Earth, the true nightmare begins. As the black hole devours rock and metal, its mass skyrockets. The planet's structure destabilizes, magnetic fields fail, oceans boil, atmosphere escapes into space. Eventually, the Earth, once blue and bright, would shrink into a dark sphere of compressed matter, then disappear altogether. The black hole remains, alone in orbit, invisible, silent, feeding on the ghosts of what once was. Is this possible? Theoretically, perhaps, but not in reality. The energy to create and sustain such a black hole is beyond anything our species could ever unleash. Even if a micro-black hole were created in a collider, Hawking radiation would cause it to evaporate almost instantly, gone before it could consume even a single atom. But this scenario reminds us of something far deeper, how fragile our world is, and how merciless the universe can be. Black holes are not evil. They are indifferent, cosmic consequences of gravity taken to its extreme. They remind us that the same physics that lets us exist can also erase us in an instant. Would humanity unite in the face of oblivion? Or would we, like everything else, be pulled into the dark?